Accords, which is the resource description schema. Accords, which provides us with the operational platform. EZVM, a new component which is now offering us an interfacing of the image system for managing virtual machine images. There's the Pass4Dev, which is work underway. The first year of CompatibleOne was very much involved in providing for the infrastructure provisioning. Since the beginning of the year, we've been working very hard with the second layer of cloud services, being that of platform as a service, and the work is moving forward very well. And UNIDATA is this data interoperability model which we're hoping to build on top of the CDMI interface. So, chords and accords, or accords and chords, A-B-4-C. As usual, we have 4 quadrants. It's getting kind of clearer and kind of more complicated at the same time. The central hub, we've now positioned the 4 critical components in the diagram: the publisher, the security services, the monitoring services, and of course the concept of the chords model. In the first quadrant, the SLA management system will produce a manifest. Now, the SLA management system is an entity which has not been implemented but is recognized, and work is currently underway, work in the sense of discussion and research for the appropriate techniques for the management of SLAs. Within CompatibleOne, we recognize 2 layers of SLA: the SLA between the customer and the platform, and the SLA between the platform and back-end providers. So that is really what complicates the scenario. Anyway, from the SLA, there is the production of the manifest. The manifest is the submission to the provisioning system, or the brokering system, of the description of the work that is to be performed. The manifest will be processed by the parser. It will activate accountancy within the SlapGrid system, and the parser will process the manifest in such a way that the elements within the manifest are validated against the XSD schema that describes the XML document. Not only does it validate the schema, but it provides the functional operation of the integration of these elements within the platform. The platform should be seen as a collection of modules, each offering a collection of category managers. A category manager, it's a kind, it's a resource, it's a concept which comes from OCCI. So each element in the manifest corresponds to a category in the system of CompatibleOne. The parser will build a category instance for every element it encounters in the manifest, and will tie up the elements together to provide and build a fully qualified provisioning plan which represents the infrastructure and software that is required as described to fulfill the needs of the initial requirements of the user. Now, the plan, once the parser has processed the manifest, it leaves the plan, which can then be used many times by the broker to perform provisioning. So the plan is, as I say often, the blueprint. Once it has been built, it sits within the system and can be used again and again and again to deliver what we would call a product. Now, the product is rather like a key, okay, the key for the car. It's not because you've got the key that you use the car. So the broker will produce a service, and the service is a collection of contracts. Somebody's speaking. And the broker will read the plan, and through the plan it will negotiate a collection of contracts through the proxy with the back-end providers. Now, before it does so, it will use the satellite services, such as CONES, the COS, which is the placement services, the energy efficiency services, the ordering and billing and accountancy services, will all assist the broker in its task of choosing the required provider through which it will communicate via the proxy. This allows the negotiation of the contract, and the collection of contracts together form the service that will be delivered finally to the initial user. Now, this brokering operation of the plan can occur many times. So once the configuration has been processed to become a plan, it's a guide that can be used many times, in the same way that software can be compiled to make a program which can be used several times. The basic model of chords hasn't changed. We still have the manifest, which comprises a collection of nodes, the node described in terms of infrastructure. The infrastructure is described in terms of network, compute and storage. These are the basic elements which come from the OCCI specification, or the OSCI specification. Underneath we can see the entity, resource, link and mix-in relationships. Below that there are the kind and action entities as well, which make up the descriptive language of OCCI. Now, everything within the chords platform, or the chords platform, is an OCCI. So, each of these elements are all valid derivations of the underlying OCCI descriptive system. I was in Oxford several weeks ago, and they were trying to position themselves, the OCCI group, and I said to them, really what you've got's a language. Okay? You can't expect to standardize all the programs that were written in languages. That's other people's job. You've got to keep the solid core language solid and tidy and make sure it doesn't become something unwieldy and unmanageable. So CompatibleOne is like a program written in the OCCI language. So the node has an infrastructure which also has the image. The image is the software component, the infrastructure is the hardware component. The image is described in terms of the system and the packages, which are the collection of software increments required to transform the system from the base operating system to the software required to fulfill the task required of this node of the manifest. The manifest is like a class. The node is like instant members of the class. We have a construction section of the manifest, which is the configuration, which can provide actions to position the nodes in a certain state with respect to their underlying software to make them usable for the task in hand. Configuration can specify requirements and can also specify monitoring needs. The manifest can be associated with an account and consequently with a collection of users. A node can specify directly its provider type, or it can leave that open for choice by the platform. The provider type may be OpenStack, OpenNebula, 4C, Windows Azure, and there are other provider types currently being worked on. The EC2 is not very far. The processing of the manifest by the parser gives us the plan. The plan is will be instanced to produce service, and the service will comprise a collection of contracts, each contract representing each node. The contract will have a provider associated. This association will occur with the placement engine, which is currently being worked upon, and it will also need the association of a profile or a subscription account through which the provider will allow use of its provisioning system. Instructions are associated with contracts. Instructions come from the configuration actions. They're the instructions required for monitoring. They're also configuration, personalization, and also for installation of software. Again, everything is an OCCI derivation. Now, the OpenStack Nova provisioning system of CompatibleOne is shown here, where the user submits an instance action. In other words, he wants to instance a plan, sends the request instance plan to the broker. The broker communicates with the publisher to localize the proxy. The broker will send a REST message to the OCCI request to the proxy for the instantiation of the contracts required to fulfill the service. The proxy will communicate with the publisher to find the OpenStack proxy. Will then communicate directly with him, and the OpenStack proxy will encapsulate OpenStack. Currently we're using the Nova interface. Very soon we'll be providing a new OpenStack proxy, which will be using the OCCI interface of one of the members of the OCCI committee, which is a much more one-to-one interface. Likewise, we have the same scenario here for OpenNebula, exactly the same schema, and we'll also be providing a new OpenNebula proxy encapsulating the OCCI interface, which has been done by another member of the OCCI working group, such that we'll have two different ways of provisioning through OpenStack and OpenNebula. one through the standard Nova interfaces on OpenStack. OpenNebula, it's the old pseudo OCCI interface. We'll have the new real OCCI interface for OpenStack and the new real OCCI interface for OpenNebula. This is work that is underway. So, since the beginning of the year, there's been quite a major step whereby, compared to the last year's work, we're able to produce actually the application image real-time and live. So the parser is processing the manifest. When it discovers that a particular node is already resolved in terms of provider type, it will engage image production through the image production service. The image production service will provision a machine, perform all of the software tasks required to install the packages, and when the installation is complete and the configuration has been performed, it will save, snapshot the image and reference it through the EZVM system as being the image to be used for the virtual machine application image to be used for the logical image node. The parser passes the plan to the broker, who will, through the proxy, reach the provider proxy, who will contact EZVM for the information as to which was the final VM for such and such a provider type, and then he will deploy it. So we now have a fully end-to-end complete provisioning system whereby the software description is performed inside the manifest, and from a base operating system as provided by platform provisioning providers, we can build on a Ubuntu or a Debian or a Red Hat and so forth. We'll install all of the software required, produce the image, and then provision. Chords has also evolved to become a fully object-oriented descriptive language. Previously, the node could only be described in terms of infrastructure and image. Today, the nodes can be described in terms of manifests, and this can be nested to any depth. So, one node through one manifest could be representing a complex configuration, and in this way, we intend to represent PaaS platforms, because PaaS platforms will be described in terms of their manifest, and consequently will be usable within other manifests as provisioning systems in their own right. But here we have the example of the PaaS platform. The PaaS is described itself by the CompatibleOne manifest. It will be provisioned through the broker and proxy, and once it has been brought live, the PaaS proxy within the provision system will hook back to the publisher to make itself known to its janitor system. It will publish and pass its resource manifests and its service manifests. Resource manifests are required such that the PaaS can allocate resource to satisfy requests for service. Manifest type 3, these manifests will describe the service itself. The parser has been changed recently and extended to encompass this. These manifests can be described using the same semantic, but with different terms and different category descriptions and attribute collections that are required to describe the PaaS. So new types of manifest will start to come around depending on the different PaaS platform types. We're busy working on the GPaaS platform of Bull, which will be classified through the manifest GPaaS, which will then describe the application products. But unless there's going to be a talk about that later on.